Hello, good morning and good afternoon, everyone. My name is Davide Villa. I'm the Chief Revenue Officer at Xinnor, and today I have the pleasure of having with me a guest from Supermicro. So, Alan, why don't you introduce yourself?
Okay. Hello, everybody. Thank you so much for taking this time to attend this webinar. My name is Alan Liu. I am a Senior Product Manager on Storage Architecture Solution in Supermicro. I'm based in Silicon Valley. I'm super excited today to have this opportunity to join David and the Xinnor team to share the extreme performance storage solution that is formed between the products from both companies. I also want to say thank you to David and Xinnor team to give me this opportunity. Thank you.
Thank you, Alan. Let me remind everybody, before we start the presentation, that you can ask a question through the chat, and we will take all of your questions at the end of the presentation. So let me kick it off. Very briefly, the agenda, we will give a quick introduction of both companies, really quick, and then we will mention the big news of our engagement, the reseller agreement, before diving into some of the technology of Supermicro and the NVMe storage portfolio. We will remind our partners about xiRAID value proposition, but the bulk of this webinar is about explaining the solution to set up xiRAID in high availability on Supermicro dual node server. So let's start from Xinnor or Xinnor, depending on where you are on which side of the ocean you are. We are a startup company founded in Israel 3 years ago, but with much longer background, with over 10 years of experience in developing software RAID for a high performance storage. And that's all that we do. We just focus on data protection at the maximum possible performance. We're a relatively small company, but probably the largest company in the world focusing on RAID, the largest team in the world focusing on RAID for NVMe. And even though we're a young company, we already have many partners selling our technology and many petabytes of NVMe storage protected by our software. Hundreds of petabytes of storage. As you can see in this chart, we have some very nice recognition from multiple analysts, but the one we are mostly proud of is that despite we are a very small company, we are part of the IO 500 list, and we're actually ranked number 2 in the IO 500 list for lasted 10 client research deployments. And we aim to get to number 1 position pretty soon. So with this, let me hand it over to Alan for a quick introduction of Supermicro.
Sure. Yeah, let me introduce about Supermicro. Supermicro was founded in 1993 in Silicon Valley, California. And the Supermicro fiscal year is between July 1st to June 30th next year. So this is a little bit about our revenue in the past few years. For our latest one, FY24, the revenue was $14.9 billion. And FY23, that was $7.1 billion. And FY22 was $5.2 billion. So you can see the company's growth in the past few years. And the locations, we have worldwide locations, 4 locations. Headquarters is San Jose, California. We have a campus in Europe, Netherlands, in Taiwan, and in Malaysia, and some other remote locations worldwide. The production capacity for us is that for today, calendar year 2025, the production capacity is $50 billion. That's the yearly production capacity. Among them, about 5,000 air-cooled racks can be produced per month, and about 3,000 liquid-cooled racks can be produced per month. Human resources headcounts totally worldwide, there are about 7,000 employees, and among them, 50% are R&D and technical. The key growth metrics is that we are the #1 generative AI and large language model platform, over 500% year-over-year growth in the acceleration computing field. So let's go to the next, David.
Yep.
Yeah, for our Supermicro advantage, we build the right scale IT solutions optimized for our customers' business goals at every step in our highly integrated supply chains. With over 30 years technology leadership, Supermicro meets the needs of the entire data center with a portfolio of application optimized systems, cluster level design, and on-site services. We have advantage in the following aspect. In the architecture, our R&D is from the component level all the way to a data center level. And for production capability, we have a worldwide production sites with accelerated time to market capability to serve our customers. Solution design, engineering, and the integration teams develop and validate the solutions, including the storage solutions, including computing solutions, including AI solutions. And our deployment is plug and play service style for a seamless deployment. So we will see a successful story in the next few pages. Let me go to the next, David.
Yeah. Okay. So as I mentioned at the beginning of this call, one of the reasons for arranging this webinar is to announce that in calendar Q1 this year, Xinnor and Supermicro sign a reseller agreement, which enables Supermicro to sell our RAID engine for NVMe called xiRAID on the entire NVMe server portfolio of Supermicro. So if you have any request for NVMe RAID protected, NVMe server RAID protected, you can contact your Supermicro sales team. There is a list of pre-qualified servers, and we can also work with Supermicro on getting our RAID engine enabled on SKUs that are not yet in the qualification list. Again, over to you, Alan.
Okay, sure. Yeah. Let me share with you guys a good story that you know that XAI was a big news in the AI industry last year. So you can get more detail about this news from the link I posted here at the bottom of the slide. This is from the Serve the Home, that is the media. They put this article. XAI is the largest liquid-cooled AI cluster on the world. It had 6,144 Supermicro AI system, that is XGX. Each system has 8 GPU in it. And this is a multi-billion-dollar project that was deployed in 122 days. This is the deployment story I just mentioned earlier. And the basic building block for the XAI Colossus is the Supermicro's liquid-cooled rack. The main parts for this project is that first is the Supermicro NVIDIA XGX system. The second is NVIDIA Spectrum X Ethernet networking platform. And the third one is the Supermicro liquid-cooled solution. So we will see that in the next page. Go to the next, David. Yeah. This is about a Supermicro liquid cooling solution. It is a total solution that include a couple of parts. On this picture in the middle, it shows that the first one is the direct-to-chip liquid cooling technology. Liquid circulates directly to a GPU or CPU cooling plates to take the heat. The second one is a CDU, that is a coolant distribution unit. It controls the cooling liquid to deliver the liquid to the chips and circulate the liquid. The cooling tower is the central facility that to do the heat exchange that brings the warm water and cool it down and have the cool water to come in to the system. And there are also some other gears, for example, a chilled door that will observe the rest of the heat from the racks. These are the complex technologies, and Supermicro is a clear leader in this field. Next, please. I also want to share with you all about Supermicro, the latest AI solution. And I believe it is very important to all of you. With NVIDIA Blackwell, these are our latest AI platforms. The first one on the left is the 4U liquid-cooled NVIDIA HGX B200 system. The middle one is a 10U air-cooled NVIDIA HGX B200 system. And the third one is the rack solution. It is NVIDIA GB200 NVL72. In the rack, there are 72 GPUs, and it has a Grace CPU, also from NVIDIA, and it is liquid-cooled. So next, please. So next, I'd like to talk about Supermicro's petascale enterprise data center storage form factor that stands short for EDSFF storage series. The petascale means petabyte scale storage system. This is the broad range of the all-flash product line featured latest technologies. The features include Intel and AMD CPU. It is 1U or 2U units, up to 1 petabyte of capacity, as mentioned, with the new technology like E1.S, E3.S, TLC, QLC, and CXL drives that are supported. And they are optimized. They have optimized the thermal management with EDSFF to enable the high density of the storage. It has a balanced throughput and performance design. It has a front SSD and a rear I/O design that make the system to be balanced. Up to 30 million 4 kilobyte random read IOPS and over 230 gigabytes per second, 128 kilobyte of serial read throughput. That's very high throughput. The target solution for these product lines that include the HPC parallel file system. It could be used for high performance AI storage-defined storage. It could be used for virtualization and VDI use case. HCI, that hyperconverged infrastructure, high performance object storage, as well as high performance CDN and video streaming application. Next, please.
Okay, a little bit about xiRAID. So you saw from Alan those very beautiful rack full of GPU, and how do we keep those GPU busy at all time and make sure we minimize idle time? The solution is to use flash-based storage systems. But when it comes to flash, you need to be careful on how you implement data protection. If you look at the various options that are available in the market to implement the data protection on NVMe drives, they all fail to deliver the performance expectation that you have from those drives. Hardware RAID is limited by the 16 PCIe lanes, so at best it can address 4 drives at full performance. Software RAID was designed for HDD, so it's far from delivering the performance of NVMe drives. And we don't believe GPU RAID makes much sense for NVMe, for high-performance storage overall, because you are dedicating one PCIe slot and 16 PCIe lanes just to run the storage, when in reality you get plenty of performance from your CPU, and there is no need to waste additional resources. As a matter of fact, our software, xiRAID, it combines 2 main technology. We use AVX technology on the CPU, so the vector extension, which allow us to run very fast checksum calculation. And we combine it with our lockless data path. Lockless data path mean that we can dynamically allocate the stripe to the available core, so that we can evenly distribute the load across all the available CPU core. That's our secret sauce how to avoid a spike of load on a single core and maximize the performance of the NVMe drives. So what's the benefit of implementing xiRAID? It's all about performance, and performance matters in normal operation, but equally important, it matters during degraded mode. If we are busy rebuilding a drive, we can rebuild the drive faster than anything else, so that we can keep the performance to the application almost stable, as if there was no disruption at all. The other advantage is it's purely a software solution. No need for any special hardware, so no need for dedicating any extra real estate inside the server for running the storage. And it's very feature rich. We support RAID migration, restriping, and many other features, including high availability, which we will be describing later on in this presentation. In terms of RAID level support, we support any RAID level, including 7.3, 3 drives parity, or all the nested RAID, 50, 60, 70, including M+M. So traditionally we call it a RAID engine. You might want to call it erasure coding technology. Now let's talk about high availability. High availability is extremely important in mission critical applications. And if you go on the Supermicro website under the solution, you will find this joint white paper, which describe how we set up a highly available cluster in a box by combining our xiRAID software with the Supermicro dual node server. Alan, do you want to describe this server?
Okay, sure. Yeah, this server is used in the white paper. It's just one of the systems that we use. Actually, we have so many models that are supported by Xinnor solution. So for this system, the model number is SSG 221 EDN 2R and 24R. This This system is a HA storage system. There are 2 nodes in one chassis and 24 dual-port NVMe drives in the chassis that are shared by 2 nodes. The access is controlled by the application, and in this case, it is Xinnor and the PaceMaker application that control the access to the drives. Each node, as listed in the table on this page, single CPU for each node, up to 2 terabyte of memory, and 2 16-way PCIe 5 slots, and also 2 8-way PCIe 5 slots. And you can utilize these slots for your high-speed I/O connections. And each one has M.2 NVMe drive as a boot drive. So go to the next.
Yep. Okay, so let's talk a bit about how we implement high availability. As Alan already mentioned, we integrate xiRAID with a PaceMaker agent. So we develop our agent within PaceMaker to be able to build an HA cluster with this server. And by doing that, we're able to protect not only from drive failures on each of the nodes, but we're also able to protect from a complete failure of one of the 2 server nodes. How does it work? So it works by being able to create RAID groups on the 2 independent nodes, and be able to fail over and fail back those RAID groups in case of a failure of one of the 2 nodes. So RAID groups are created on each of the server via xiRAID, and then the resource agent exposes xiRAID instances to PaceMaker. And through Corosync and CC2, we make sure that there is always a synchronization between the 2 nodes, so that there is no risk of data loss or other issue like a split brain or any amnesia or any other issue that might happen in a HA type of implementation. So we ran some experiment on this box, and we use 24 Kioxia CM7R, the read-intensive drives. So what we did, in order to get access to all the drives at the maximum performance, we split each of the drive in 2 namespaces. And we allocated namespaces, the first namespaces of each of the drive to the first server, and the second namespaces of each of the drive to the other server. And to maximize resiliency in this test, we selected a RAID level 6, which is capable of surviving up to 2 drive failures, or in this case, 2 namespaces failure. And to get optimal performance, we decide to create 3 independent RAID groups per server by using 8 namespaces for each of the RAID group. So how does it work? As you can see in this diagram, you see that we have those 3 RAID groups per server node, each of them taking data from a portion of all of the drives. And what happened in case one of the server fails? In the picture number 2, you see server node 1 failing. Through the agent on PaceMaker, we're able to fail over the RAID groups that were originally on server node 1 into server node 0. And then once server node 1 is back running into the operation, we automatically fail back the RAID groups, the original RAID groups. So all this is automated, and there is no need for a user intervention. During our test, we also measure performance. So if you look at this chart, it has 4 different columns. In the first column, you can see the measure drive performance, the performance we were getting from the 24 drives. In the second column, we calculated the theoretical maximum performance that we can achieve under RAID. As you can see, when it comes to sequential read, the theoretical maximum performance is equal, under RAID is equal to the performance of the drive. When it comes to write operation, we need to take into consideration the parity. And when it comes to random write, we also need to take into consideration that there are multiple operations involved to read the parity, update the parity, etc. So what you see in column 2 is the maximum possible performance that you can get from any RAID, not just from xiRAID. And in the third column, you can see the performance that we managed to achieve. So in brief, we managed to achieve between 95 to 100% the theoretical maximum performance that the hardware technology can allow us. And those are great absolute numbers by themselves. So those numbers are more than sufficient to keep multiple DGX boxes busy at all time. So what's the use cases? So you can use this solution, the combination of xiRAID and Supermicro HA server, for different purposes. You can use it for block storage, for example, for a database, high-performance databases. You can use it for a high-frequency trading where latency and random operations are extremely important. Or you can use it for network packet capturing where you need data protection at extreme performance. When it comes to AI, we see the possibility to use this platform as a foundation for file storage, and it can be a great solution for NFS over RDMA appliance, or it can be the foundation of a larger cluster of storage by implementing a parallel file system like Lastre or BGFS. Actually, in this slide, you see the architecture of how it would look like in a Lastre type of environment. So we can have multiple of those servers connected to the Lastre network and become a federated cluster of storage with no single point of failure, with RAID protection from drive failures, but also technology to protect from individual server node failures. So in brief, to conclude on this webinar before we move to the Q&A, the combination of xiRAID Classic with a Supermicro storage bridge-based server, the dual node server, allows to build a cluster in a box which provide extreme performance over 200 gigabytes per second, as we saw, with ultimate level of resiliency, so we can survive multiple drive failures and we can survive a complete node failure. So this solution can serve multiple purposes, from block storage to file storage, and it can be the foundation of large cluster deployments. Okay, so I think with this, we can start going through the question that we received. We receive quite a nice list of questions. So let me read the question, Alan, and then whether they pertain to us or to you, Alan, we will decide how to answer. So the first question is actually for me. It's about when xiRAID will be supported on Supermicro Bluefield 3 based JBOF. Well, actually, it's not just for me; it's for the two of us, Alan. So the software that we've been presenting so far is called xiRAID Classic, which requires AVX technology on the CPU. But we have been actively developing our user space version of the code, which will go in full production by the summer of this year. That version of the code is called xiRAID Opus, Optimized Performance in User Space. So as soon as we will have released xiRAID Opus, we will be able to start qualifying Supermicro JBOF based on BlueField-3. We already demonstrated that in a partnership with NVIDIA that we can run xiRAID Opus from BlueField-3. So we just need to do the complete validation of the solution on the JBOF itself. I don't know if, Alan, you want to add anything about the availability of the JBOF itself on BlueField-3.
Yeah, so we do have the JBOF that actually we did some testing with Xinnor solution as well as our solutions. So yes, the answer is yes. Yeah, we do have the JBOF and the JBOF is supported. Yeah.
Okay, so the next question is about, so let me read the question. Is there any limitation on CPU maker models? Will xiRAID work on AMD servers? The answer is yes. Both AMD and Intel support AVX2. They also support AVX512, but we only need AVX2 to run our checksum. So there are no limitations in terms of CPU utilization. And when it comes to xiRAID Opus, we're also able to run from ARM processor. BlueField-3 is based on a 16-core ARM Cortex-A, which we already had the opportunity to test and validate. But theoretically, there are no limitations to run on other ARM-based processor. Following question, what's the TCO compared to hardware RAID? Great question. So when it comes to hardware RAID, as I said, you are limited by the number of PCIe lanes. So the hardware RAID goes through a 16 PCIe lanes PCIe bus, and every NVMe drive, they comes with 4 lanes. So by design, if you have more than 4 NVMe, you are limiting the performance. And even with 4 NVMe drives, you cannot get the full performance of those drives because the limited capability of the ASIC on the hardware RAID. So hardware RAID is a great technology when you deal with HDD. It's a good technology when you deal with slow media, like slow interfaces like SATA and SAS. When it comes to NVMe, they just fail badly to deliver the performance. So the TCO is very easy to explain. If you spend money on NVMe devices and then you're bottlenecking those devices by using hardware RAID, you're just wasting money. Following question. Is it possible to export this solution RAIDs as NVMe over Fabric targets, for example, with SPDK? Yeah, that's a great question. So to address this type of deployments, that's the reason why we are developing a xiRAID Opus. With xiRAID Opus, we support NVMe over Fabric target and initiator. And it's actually starting from the SPDK libraries. So we started from the SPDK libraries and we modified some of the modules within those SPDK libraries to get a robust and very fast RAID implementation. So stay tuned. xiRAID Opus is about to come in July timeframe, and that will be the ideal product for the use case that you just mentioned. So the following question, is the presentation available to all attendees? Yes, it will. We will make the recording available afterwards. and we will distribute the presentation as well. Can SBB configuration work with mixed drive types, or must they be identical? Okay, that's a good question. So when we talk about a RAID, the performance of the RAID depends on the speed of the slowest drive within the RAID. So if you mix a drive with different performance within the same RAID group, you will limit the performance of the faster drive. So it's not a good practice. It is possible. It's not a good practice. You can do it, but what you can do, you can create different RAID groups for the type of drives that you have within the server. So you can have some high endurance drive or mixed workload drives for metadata for under Lastre, and the best practice in this case would be to implement it in RAID 1 to protect the metadata. And then you can have a read-intensive drive for the OST, for the data. And in that case, you can use a read-intensive drive. So as long as you create independent RAID groups, yes, you can mix the drive. Don't mix the drive on the same RAID group. And with our software, there is full flexibility, because we sell the software, the license per drive, so it doesn't matter. It doesn't make any impact on the cost of the overall solution, of the overall license cost, if you create smaller RAID groups or if you create just one very large RAID group. Okay, the following question is, how many customers have implemented? So let me answer in two ways. So when it comes to xiRAID, we have a huge number of, let me rephrase. We have a very large number of customers. As I say, this technology has been in development for over 10 years. And as Xinnor, we are selling this technology since the inception of the company, so 3 years ago. When it comes to high availability, we already have very large deployments. We deployed last quarter over 20 petabyte at multiple universities in high availability. When it comes to high availability on the Supermicro SBB platform, that's something really new, because the Supermicro server was just released at the end, in mid of Q1. And we had all our testing done during the quarter. So for now, we have some POC going on. We don't have an active customer on this solution yet, but that's why we're having this type of webinar, to promote the solution and to look for customers who are eager to start the POC. Okay, I think this was the last question I see on the chat box. We still have a couple of minutes, so if you want to ask some additional question, please go ahead. Or if you have any comment, Alan, to...
Sorry, I'm trying to see that question. What's the question?
No, there's no additional question for now. I was asking if you have any additional comments that you want to make.
Yeah, so I don't have any specific question. I just want to say that so for our work together with Xinnor to test this solution, it really got a very good result in terms of the extreme performance and the high availability storage. So this is a very good story that I hope that can benefit, customers can benefit from this solution.
Thank you, Alan. And yeah, I echo what you just said. And let me remind everybody that this is just one of the solutions that we can have with Supermicro. So if you need a high availability, that's a tested and readily available solution. But in case you want to implement xiRAID on a single node server, that's also possible. And we have a list of servers that are already qualified, and we can have multiple new server qualified on demand. So feel free to hook up with your Supermicro sales rep, and they will work the way internally to make it happen. So with this, I think, there is one last message. Let me see if we can address it. Okay. Yeah, it's not a question, it's just a thank you. So, so let me thank everybody for attending. Thank you, Alan, for your participation in this presentation. And thanks to Supermicro for the partnership. Looking forward for many more.
Thank you, David. Yeah, it's a pleasure. Thank you. Thanks, everyone.
Thank you. Have a good day. Bye-bye.
Bye.